Welcome to DevOps Project Live Implementation. So till now we have completed two projects, IT Software Company Portal and Bank Portal Financial Calculator. So these two projects we have completed. So now let's start with project 3. So that is e-commerce portal using Azure Kubernetes services and Azure Container Services. Okay, let's start. So project 3, e-commerce shopping portal. So tools we are going to use is, so Terraform we are using, and the front-end application is React.js and backend Spring Boot, and DB we are using MySQL, and we are using Kubernetes manifest and Dockerfile, and Azure services we are using is Azure Kubernetes services and Azure Container Registry, and of course we are using Helm charts and Nginx load balancer, and we are using Azure DevOps tools like Repo and Azure pipelines. So let's see. Codes overview. Project e-commerce shopping portal. So this part is designed to provide an interactive web platform. Okay, it allows users to browse a large variety of items. Okay, they can add the items to their chart and proceed to purchase. Okay, during checkout, users provide the address details for delivery. Okay, this is a real-time online shopping portal which enables customers to purchase the products from online. Okay, it is similar to Amazon, Flipkart, and etc. Okay, let's see. Yeah, so here we go. So this is the e-commerce shopping portal where we can able to see multiple products. So once you click the product, so we can purchase this one. So we need to provide the user details for delivery. We need to provide the user details. You need to provide the address and the phone number. You need to place the order. So once the order is placed, this data will be processed by the backend. It will be stored in the database stream. Okay, so database stream will be hand over the details to the corresponding client. So he will deliver the product to the corresponding user. Okay, so this is the architecture. So we will going to discuss deep about this one. Let's see. Azure services and DevOps tools we are going to use. Infrastructure as a code tool, Terraform. So it will be help for provisioning all Azure services to front end. So we will develop the front end application using React.js that will be hosted on AKS. Backend. We will be developing Spring Boot application that will be deployed in AKS. Database. We are using MySQL that will be hosted on AKS, and of course we are using Dockerfile and Kubernetes manifest. So these help us to build the Docker image and deploy in Kubernetes services using Kubernetes manifest. I will show you how to build and how to deploy. And we are using Helm chart that will install the Nginx load balancer. And we have a ingress controller. It will be route the traffic from public IP to front end. Okay. Of course, you are using Azure DevOps. So we will using Azure repository for storing the code. So we will use the pipeline for triggering your pipelines. We have multiple pipelines: front end, back end, and infra, pre-infra, cleanup, and ingress installation. Okay, let's see about instructor. So let me introduce about myself. I am Prasanna Kumar. I have overall 15 years of experience in IT industry. So I have worked on different kind of DevOps roles. So currently I am working on topmost MNC company, and I have working experience on different kind of projects. Starts with banking project, automobile, travel and transport, and medical care, telecom domain, and big four companies. Okay, so I have multiple certifications. So most important one are AWS DevOps certification and Azure DevOps certification, and basic certifications like Azure fundamentals and AWS fundamentals and etc. and so on. Okay, thank you. What you will achieve at the end of this course? Okay. So one, been able to develop and deploy the front-end application, that is React.js on AKS. Okay. Two, you can able to develop and deploy the back-end application Spring Boot. So this is used for business logic. It will be deploying on AKS. Okay. 3. You can able to write the Terraform script that will provision the Azure resources for your requirement purpose. 4. You can able to write the Docker files and you can able to create the Kubernetes manifest that will be helping deploying your application in AKS. And 5. You can able to establish the connection between front end to back end and DB. Okay. So you can able to learn how to build the Azure pipeline for CI/CD pipelines. You have infra pipeline, front-end pipeline, back-end pipeline, cleanup pipelines. Okay. So with this, you can able to learn the real-time DevOps project for your portfolio. Okay. Architecture and tech stack walkthrough. Let's see the architecture of e-commerce portal. Okay. Let me zoom this page. This page. Okay, you can see architecture of a e-commerce portal. Okay, so you can observe the multiple components. We have AKS services, we have ACR, we have Azure pipelines, we have Nginx load balancer, and you have multiple components of a Kubernetes. Okay, okay, let's see the flow. So let's start from global users. So users access the portal via public IP that will be managed by Nginx load balancer. Okay. After that, we have ingress and routing. So these requests are directing to ingress port in the Nginx namespace. Okay. These will be routing traffic to front end and back end based upon their path they have configured in AKS. Okay. So let's come to application services. We have front end services, we have back end services, we have database services. Okay. So the front end. So these will be engaging users for browsing and purchasing their products. Okay. Now come to backend. So we have backend. It will be handling the business logics like orders and user addresses. Okay. So now come to database. So database. So backend will be communicating with the MySQL that will be storing the data of the users. So this will be helpful to deliver the products to clients. Okay, we have PVC. These will be helpful for storing the persistent data. Okay, that means if the parts are deleted, still the data will be storing PVC. Okay, so let's see about security features. So security and identity, we have RBAC. So it will secure the access to the resources. That means so the secure connection is established between AKS and ACR. Okay, so you can observe the Azure pipelines. This will be helpful for CA and CD deployments. So of course you are using a infra and pre-infra and Helm pipelines also. Let's see what let's see the workflow. Okay, so we have the Azure pipelines, we have the developer. So developer will develop the code, and once the code is ready, he will push to the Azure repository. So in the this Azure repository, pipelines will be triggering automatically. We have multiple pipelines. So let's start with the pipeline of pre-infra. We have pre-infra pipeline, we have infra pipeline. Let's see each one. Okay, we have multiple pipelines. We have pre-infra pipeline, we have ingress pipeline, we have infra pipeline, we have front-end pipeline. So cleanup pipeline, backend pipeline. Okay, let me break each one. So let's start with pre-infra pipeline. So pre-infra pipeline, this will be so this will help us to create the Azure container registry and resource group. Okay, once the pre-infra is completed, now comes to infra pipeline. So infra pipeline, this help us to create the Azure Kubernetes services and IAM role. Okay, so that role will be helpful for accessing the Azure container registry to Azure container services. That means so AKS can able to pull the image from ACR. Okay, so this is the infra pipeline. Now come to Nginx. Sorry. Now come to ingress pipeline. So this ingress pipeline will be helpful to create the Nginx load balancer using Helm chart. Okay, so that will show you how to install Nginx load balancer using Helm chart. Okay, so after that we will go to front end pipeline. Okay, let's see. So we have front end pipeline that will be build the Docker file and it will ship the image to ACR. Okay, we have deploy pipeline that will be deploying your corresponding image, whether it is a front end or back end. So it will be taking the image and deploying in the pods. Okay, like this, your application will be updating when a change is detecting in your pipeline. Okay, so like that, front end and back end will be deploying both. So once the deployment is completed, so it will be look like this. These all components are deployed. Okay, let's see the workflow. Let's see the walkthrough. So user access and entry point. So users access the portal via public IP managed by Nginx load balancer. Okay. So we have a public IP that will be accessed by global users. So if you need a specific DNS name, you can configure. It's like similarly www.amazon.com or www.flipkart.com like this. You can configure this public IP. Okay. So now we have a public IP that will be used by the users. That will be used by the users. Okay. So we have ingress and routing. Okay. So now the request will be routed to the ingress pod. Okay, we have configured like this. So from Nginx load balance to ingress pod. So ingress pod is responsible to route your traffic to corresponding services. Okay, you have multiple services. You have front end services. You have back end services. You have DB services. Okay, based upon path, it will be routing. So by default, it will be opening the front end page only. So since dash is a empty path, so it will route the traffic to the front end. So we have a dash API. So when a change is detected in path name of your front end, so it will be routing to backend. Okay. So in the backend, it will get some string. That string having some information that will be processed by this backend application. Okay. So once the data is processed, so that data will be stored in MySQL. So that data is stored in MySQL. Okay, like this, the workflow will be happening. Okay, let's see. So application services, front end service. So it engages users for browsing and purchase. Okay. So backend services. It handles the business logics and orders and user addresses. Okay. Database services. So we have backend that will be communicating with MySQL DB. Okay. So we have security and identity. So RBAC secure the access to the resources. Okay, it will connect the AKS to ACR. Okay, and we have the part of CI/CD and deployment and pipelines. So of course these are the part of Azure pipelines. Okay, let's see how to implement this each and every step. So you need to understand very clearly that traffic will become from Nginx load balancer, then to ingress, then to front end, so from front end to back end, from back end to DB. Okay, like this the work will be flowing. So if a change is detected in pipeline, so it will be triggering, it will pushing image to the content registry with the help of a build pipeline. So with the help of a deploy pipeline, so these will be updating with the latest image. It will be pulling from ACR. Okay. So for this purpose, you need have the permission. So we have managed identity and RBAC. So that will be helpful for pulling the ACR image. Okay. Like this, a new image will be coming to ACR. It will be deploying. Okay. This is the workflow. Let's see. 2. Environmental setup. So pre-request. So you should require Azure subscription and you should require Azure DevOps organization. Okay. So if you want Azure DevOps organization, you need to create. Okay. It's a matter of just a single click. Okay. So once you got Azure subscription, you need to go here and you need to create that one Azure subscription. I already told you earlier. So go to here, home directory. Yeah, here. So new organization. So click new organization. So you need to pass the name. That's it. ADO is created. Okay, come to back. Okay. So local tool setup. Okay. So Node.js. So for front-end application, you require Node.js. So you need to install Visual Studio Code for code editing purpose. You require Git for version control tool. So you require Maven and Java. So to develop the backend application, you need to require Maven and Java 18. Okay. So after that, you need to procure the Azure pipeline agent. This is optional one. If you have default Microsoft pipeline, you can use the same, or else you can procure the VM. For that purpose, you need to create a virtual machine. You need to attach it as a pipeline agent, and you can use the same name in the pipeline. Okay, like I have done in the project one. Okay, so in this current project, I'm using the my separate pipeline agent only. Okay, so after that, you need to create the Azure service principal and service connection. Okay, for this purpose also I have given a script to create. Okay, so if you create the Azure service principal, so collect that information and you can paste in the service connection in Azure DevOps project. So that is also I already show you. So go to your project settings. You have service connection. So you need to create a service connection and you can add that service principal details. So I already show you in the project one. So project repository and folder structure. So once you have created a Azure DevOps organization, you need to create a project. Okay. After creating the project, I will already show you how to create the project. Okay. Go here. So go home directory. So click new project. So you need to give the project name. So these all things will be rest as a default one. So after creating, so go here. So go to repository. Okay. Click here. So new repository. You can pass the new name, your repository name, and you can click create. So it will be creating. After that, you can click clone. So you will pass the some URL. So go to your Git. So there you need to pass the commands like git to clone and HTTP. Okay. So like this, you can download the project. So these things I already shown in project one. Okay. So once the project is created, you can create the front end and back end and ISV. Okay. So you need to follow the standard naming conversation and the Terraform backup setup you need to do. So let's see how to do. 3. Front end and back end and DB development. Okay. So this is the just title only. Okay. So once you are ready with your Git repository, we need to clone that repository. Okay. We need to clone that repository. After that, we need to do front-end development. So I already show you how to develop. So you need to pass this command npx create tab. You need to pass the name of your app. Okay. So if you need to pass that one, so it will be creating a folder. I will show you. So this is the folder. Okay, so SRC public node modules and package.js readme.md. So this will be created. This will be creating automatically. Okay, so let's see what the code it is having. So in the SRC, it is a .env. So it will be helpful for your backend connectivity. Okay, API.js and we have app.js and index.js. Index.js is the default one only. So we have created app.js. So you can see the code here, front-end code. So all the front-end code is included in this for main file. If you have separate files, you can just import that one. Okay. So you can observe all the code. So if you need to change, if you are interested on creating this front-end application, you can configure more. Okay. This is the simple page. This is the simple page. So if you want, you can configure more. Okay. So we have multiple versions like Vital, Angular. Yeah. So like this, we have multiple versions. You can use the same. Okay. So this is the SRC folder. So apart from this, so I have created the Docker file and Kubernetes. Okay. So these things we will discuss at next. Okay. Next, we need to develop the backend. Okay. So since it is a Spring Boot application, so I suggested you create using Spring Boot initializer, right? So go that folder. So you need to pass these all details, give the Maven, Java language, and the Spring Boot version, and the project metadata like group ID, artifact, name description, package name, package, Java version. If you need any dependencies, you can add and generate. Okay, it will be downloading with zip file. So you can unzip one, you can paste in backend directory. Okay, yeah. So once it is downloaded, you can able to see the code. Okay, this is SRC. So I have created Docker file and Kubernetes. So we can discuss this later. So let's see SRC. Sorry. So and also we have form.xml. Let's see the form.xml. So we have parent, we have build plugins, we have some dependencies, Spring Boot starter web, MySQL connector, and we have Spring Boot starter data JPA, and we have H2 database also. So which will be helping in locally. Okay. So go to the code. So SRC main Java com example we come like this. I have configured multiple. I have created multiple Java files. So this is the entry point for your Java application. Okay. So rest of the files will be helpful to process the business logic. Okay, go to each and every one. So controller. So this is the controller. Yeah, this is the controller. So it having request mapping dot slash API slash orders. Okay. So when the front end application is processed with correct method with the correct path dash API orders, so that will be routing to the backend. Okay, in the backend, so the business logic is set at this one. So this will be processing your data. So whether it will be input constant or string or whatever it is. Okay, so it will be processing, and we have order items. Okay, see customer name, customer address, customer phone. Okay, like this we have. So this file will process your front end data to DB. Okay, that means so it will create a separate entry to database. Okay, so go to resource. So app.api. Okay. So we need to pass the database details here, so that database will be communicated to the backend will be communicated to the database. So you need to pass the database URL, you need to pass the username, password, and rest of the things are default one. Okay. So since you are deploying in same AKS in same namespace, you are passing this as a default one. Okay. This is the cluster name. Okay, and port. So it will be communicating automatically with the help of these credentials. I already shown you, right? So we have this is the database. So it will be communicated to the your backend cluster IP. Okay, the data will be stored in MySQL. So this MySQL have a backup of PVC. Okay, so if the databases will be deleting, so that still the data is stored in PVC. Okay, like this data will be storing for forever. Okay, so let's see about Kubernetes and Docker file. We will be discuss on next slide, the next slide. Okay, yeah. So backend development is completed, and MySQL interact with backend. So I already told you how to interact. So you can check here the SRC. So we have passed all the backend details. So this is the backend details. So this is the MySQL pod. for details. Okay, you are passing username, password, so that backend will be communicating to the MySQL. The data will be flow from database to backend. Okay, so now come to Docker file development and Kubernetes manifesto. Okay, before that we'll discuss about Docker file and manifesto. So, so right now we need to deploy three different kind of services and three different kind of deployments you need to do in AKS. So front end, back end, and DB. So we should require three images and we should require three deployments. So for this purpose we need to create. Okay. So of course we require ingress. Okay. This will be routing traffic to the corresponding service. Corresponding service. Okay. Let's see. So let's see the Docker files. Okay, why it is disturbing? Okay. So come to the front end first. So go to front end. So we have Docker file. So this is the multi-stage Docker file. So stage one, this will build the React.js app. Stage two. So these serve the React.js app with Nginx. Okay, that means so the generated output of a build artifact will be deployed in Nginx server. So these will be up and running. Okay. So let's see how we have configured. So we need to take this image and working directory. We need to copy package.json. We need to install. Again, we need to copy whole application. Okay, that means it will copy all these things. The Azure Kubernetes, these all things will be copying. So after that, we need to pass some environments and arguments. So after that, you need to run this command. So npm run build. So this will compile and build and generate the artifacts. Okay. So next come stage two. So this is a multi-stage Docker file. So we are using one more image. So we are removing the unnecessary images in that image. So after that we are copying generated artifacts from build to this specific location. Okay, this is the build. So this will be a build. Okay, so this whole name is build name. Okay, from the build stage to be copying this one. Okay, so app that build. So this command will be generating this specific artifact. So we are copying from there to this specific location. Okay. So once we are copied, we need to expose the port 80. After that, we need to run this command so that Nginx, so React.js will be acted as a Nginx application. Okay. So next, move to backend Docker file. Okay. This is also a multi-stage Docker file. So we have build stage, we have runtime stage. So in the build stage, so it will be generating the artifact that will be copying and it will be running in runtime. Okay, the same process you are done in front end. Okay, this is a Spring Boot application, that is a React.js application. So we are using a Maven, we are using working directory, we are copying source and form.xml. Okay, these two are important. So we are copied. So after that, we are packaging that application. Okay, we are passing commands like Maven, package, Spring Boot, repack. Okay, so this will generate the app.jar. Okay, so after that, we need to copy. Okay, stage 2 runtime. Okay, we are using eclipse. This is image. We are setting working directory and we are copying this app.jar to this current directory. Okay, so builder. So are given stage 1 build as a builder name. So in the stage 2 we are using, you're just copying that output output we have generated, right? App.jar, that will be pasting in this specific location /API as API.jar. Okay, it will be in this specific location. After that, we are exposing 8080. So once we are deployed, so it will be started command like java you need to pass jar, you need to pass this one. This is the location of app.jar. Okay. This is all about multi-stage Docker file. Okay. You should learn how to create a multi-stage Docker file. Okay. So with this, we have completed the Docker files. Okay. Just moving forward. So Kubernetes manifest. So let's see how to create and how to deploy this one. So let's see the image. In the AKS services component, we should require these all AKS components. So we required front-end services and pod. We required back-end services and pad. We required DB services and pods and PVC. Okay. So let's see why we need to create these three. Okay. So I have created a Kubernetes manifesto in corresponding application only. So in the database, I have created a Kubernetes name, and front end also have created a Kubernetes name only. So under the Kubernetes, so I have created a three files. In the front end also I have created three files. So let's see each other. So starts with front end. Yeah. So we have deployment.yml and we have service.yml. So you can find this one. So this is the deployment component, this is the service component. So in the deployment component, we require replicas, we require a template. Under template, we require a containers. So we need to pass the image registry and image name. Okay. So we need to pass the container port. Okay. Since this is a front-end application, React.js, we are exposing port 80. Okay, we need to give the service. So we need to pass the service, we need to select the service, we need to pass the port and target port and type cluster IP. So cluster IP means, so it will be accessible internally only. Okay. So this is all about front end. So apart from this, we have in ingress.yml. Okay. So this helps us to route the traffic between front end and back end. Okay. So I already told you. So we have Nginx load balancer. So it will generating the public IP. So once the user will hit, so once they will be hit the public IP, so the traffic will be routing to the Nginx pad. In the Nginx pad, so they have routed with paths like slash for front end, so slash for API backend. Okay. So this is the API slash. Okay. Service is front end. So the name also we have given the service name is front end only. So like that. So default it will be routing traffic to the front end only. Okay. Both ports are 80 only. Okay. So in the front end, when a change is made, the path should be like this. Okay. Slash API. Any change apart from API. So I already told you the front end we have a API.js. Okay. So any change should be made in the code. So it will be routing to slash API dot orders. Okay. That means if you try to order or place the product, so the traffic will be routing to backend to process. Okay. Yeah. Let's see the code. Yeah, see here. So it will be routing the traffic to backend. Okay. So by default it will be in front end. So when you are trying to order, it will be routing the traffic to backend. Okay. So this is the nginx.yml manifesto. Let's close this one. So go to backend. Open Kubernetes. So we have Kubernetes deployment.yml and we have service.yml. See, you can see this one. So deployment. So we are given a duplicates to, we are giving a metadata. So in the template we have backend name only. So under containers you need to specify the container registry name and image name and the tag. Okay. So you need to pass the container port. So we have services. You need to pass the selector. You need to pass the port. You need to give the load balancer type. Okay. You are given a cluster cluster IP. It will be accessible in internally only. Okay. So even though if you are passing internally, why the traffic will be routing to ingress controller? You are asking the question, right? So I have mentioned that so it will be accessible in the internal only. If you have a ingress means that traffic will be routing to external world. Okay. Now go to MySQL. Since I have using the default MySQL only, I didn't writing any separate Docker file for MySQL. So let's see. So this is the backend backend deployment, backend Spring Boot deployment. So we already given the backend details, the application itself. So it will be directly hitting to the database. Okay. So so for this purpose, you need to create a MySQL. So this is the MySQL deployment. You need to give the selector, and you need to give the MySQL specialization. You need to give the image. This is the image. You need to give the these details, environmental details. So it will contain the username, DB, password. Okay, these all details you need to pass. You need to give the ports. You need to give the values. We have created a persistent value claims that will be attaching as a value. Okay, even though if you delete the part, so the data should be stored in persistent value. Okay, this is the service. So this also acted as a cluster IP. So each and every cluster IP will be generating a specific name. So the same name should have just given in the backend itself. So we are given the default name only. Okay, the MySQL will be generating this name. Okay, so this MySQL will be having a service cluster IPs. It will be open to within cluster. So your pad will be directly communicating to MySQL. Okay, so your backend data will be directly passing to MySQL only. So I have given while communicating to that MySQL. So it will use the username, password. Okay, so like this data will be passing by backend. So this is all about Dockerfile and Kubernetes manifest. Okay, thank you. 4. Infrastructure as a code. Okay, Terraform. So we are using Terraform for provisioning Azure resources. Okay, let's see. So 1. So we will write the Terraform code for provisioning the Azure infra. 2. So we will organize our project structure, and I will explain you. 3. So we will need to configure the Terraform backend. Okay. So 4. So once you will get a Azure service principal, we need to establish the service connection, and we need to utilize in the pipeline. 5. So we need to deploy the Azure pipelines. You have pre-infra, infra pipelines, and etc. After deploying, we need to verify all the resources. Okay. So I already explained you in the previous project how to do. So let's quickly go to the code and explain you each and every step. Okay, I am quickly ramping this step only. So this is a repetition step. Yeah. So let's see the IAC code. Close all the path. So go to IAC folder. So just remember what are the things you need to create. Okay. Yeah. Okay. So you need to create Azure container services. We need to create one role. You need to create AKS cluster. Okay. So these all things you need to create. Of course, you need to create a resource group. Okay. So let's see how we have created or how we have written the Terraform code. So this is the project directory. So IAC. So I have separated the key values with the dev prod folder names, and I have main.tf file and output.tf and provider.tf and variable.tf file. Okay. So the Azure commands.txt. So what are the important commands related to infra? I have stored this one. So you can use in the so when you have completed the deployment, you can use this part. Okay. I will tell you when to use. Okay. So let's see the first we will see the pre-request. So let's see the pre-request. So these pre-request will be creating so important resources. I will show you. So with the help of a pre-infra pipeline, so we can able to create a resource group on Azure Container Registry. Okay, let's see the code. So main.tf file. So for naming conversation purpose, I have given this one locals. Okay. So name prefix, I will following the standard process. Okay. So this is the resource group, and this is the container registry. So with this container registry will be creating. Okay. So we are using a specific configured step. So with this, your name will be removing dash. Okay. So there is some standard process is there for naming conversation for each and every component, each resources. So we need to follow that one. Okay. So we have main.tf file, we have provider.tf file, we have terraform.tf variable, tf vars, you have variables.tf. Okay. So you have backend.tf first. So here we need to pass the Terraform backend details. Okay. So I'm given like this Terraform dash dev.tf stage. Okay. Let's create. Let's go to main file. Let's see the main file. So this is the main file. So we need to create with the help of infra pipeline. So let's see the what are the components we need to create. Okay. So till now we have created the resource group. We need to create Azure container registry. So okay, with the infra pipeline, so you can create this all parts. Okay, AKS, and we need to create a role. Okay, let's see the code. This is the main.tf file. This is the standard naming conversation. I'm giving this one. So the upcoming projects also I'm giving this as a name standard name. Okay. So this is the data. So this will fetch the existing resource group details. Okay. So this is a Azure RM client config. So this will fetch your manage identity details. Okay, like principal ID, uh, ID, something it will be fetching. Okay. So these can be used in wherever you need to require. Okay, let's see where it will be coming. So you can see here. So object ID you need to require. So these like this you need to fetch these all details from client config with this command only. Okay. So you need to pass these two. After that it will be fetching the container registry details with the help of a data. Okay. So after that, so this will be creating the container container services. Okay. This command, and this command will create a role. Okay. Let's see. So Azure Kubernetes cluster. Okay. We need to pass the name. We need to pass the location. Resource group. We need to pass. We need to pass the DNS prefixes. Okay. After that, we need to create a node pool. So this is nothing but cluster. So your Kubernetes cluster nodes. Okay. So how many nodes need to require? One. So VM side, you need to use this standard VM. Okay. So based upon your workload, you can change this VM side. Okay. So after that, you need to use the system identity, passing the system identity, and have given the tags. So this is the standard. So standard and minimal code. Okay, minimal configuration. Okay. Once the Kubernetes cluster is created, so then we need to create a role. So this role help us to pull the ACR image. Okay. So you have ACR, right? Azure Container Registry we have already created here. So we already created Azure Container Registry. So after creating, so we need to create a Kubernetes cluster. So it should require some role that fetch the container image from container registry, right? So for that purpose, I have created this role assignment. So this will create a role so that have the capability to fetch the image from container registry. Okay. So this is the principal ID. That means your own ID. So this is the role. your assignment, scope. So under this container registry only you are can able to fetch to this container this Kubernetes cluster. Okay, you are passing your identity. Okay, so let's see the image. This is the Azure Container Registry. Okay, so this is the Azure Kubernetes resources. We have created a Kubernetes resources. So we need to create some role. So that role should have access to pull the Azure Container Registry image. Okay, so we have some managed identity. Identity is nothing but we have a service principal, right? So we have some role, right? So that role should have access to pull the container registry image. Okay, we are using our managed identity. That managed identity have access to pull the Azure container registry image. Okay, so we have created now till now we have created the IAC folder. So this IAC will be created with the help of a infra pipeline. Okay, let's see how to create these things. So after completing the overview on Terraform code, so now see the infra pipe. Now see the pipelines. So five CI/CD pipelines with Azure DevOps. So one. So setting the YAML based Azure pipelines. Okay. So we are going to create all the pipelines with the help of a YAML based only. So we are not going to create manually pipelines. Okay. Okay, let's see how many pipelines we have. So we have pre-infra pipeline. So this pre-infra pipeline that will provision the resource group on ACR. Okay. So let's after that we create the infra pipeline. So this will provision the infra users resources using Terraform task. Okay, even pre-infra pipeline also will use the Terraform tasks only. Okay, especially mentioned in infra. This is the main pipeline. My main pipeline. So 4. So ingress pipeline. So using Helm task, it will install the Nginx load balancer. I will show you how to install the Nginx load balancer using Helm charts. Okay, in the ingress pipeline. Okay. So after that, so front-end pipeline. So build and publish the Docker file image to ACR and deploy to AKS. Okay. So we will build and publish your Docker image to ACR and deploy to AKS. So that means first of all we will build. After that we will publish your Docker image to Azure Container Registry. After that, with the help of a deploy stage, we will deploy to your corresponding AKS. Okay. So after that, we will deploy the backend pipeline. So now frontend is completed. Now backend. The same task. We need to build your image and publish to ACR. After the publishing, we need to deploy to AKS using deploy stage. Okay. So we will see these all pipelines in the upcoming session. So after that, clean up pipeline. So clean up all the resources. So these will delete all your resources. Okay. So let's see the first one, pre-infra pipeline. Yeah, this pipeline. So pre-infra pipeline. Okay. So this is the YAML file. So I'm mentioning pre Terraform work directory is IAC pre request. So we have this having multiple stages, multiple steps, tasks. So this will this task will install the Terraform version. If it is not there, so if it is already there, it will just show the Terraform version. Okay. So I already told you in the previous project, this is the same steps. So one will do Terraform init, another will do Terraform valid. So after that, you will do Terraform plan. After that, it will do Terraform offline. This is the standard path for all pre-infra and infra pipelines. Okay. So, but in the pre-infra, we will just changing the working directory. Okay. Rest of the things are same. Okay. The same vice versa to infra pipeline also. You just see the difference. Yeah. See, only working directory is different. Rest of the things are same. Yeah, rest of the things are same. Okay. So we are using service connection, and this is a bash script, and we have the inline script. So we need to pass that one. Okay. The same process is same for infra pipeline and pre-infra pipeline. Okay, let's build the pre-infra pipeline and infra pipeline one after one. Okay, after that we will deploy infra pipeline. Okay, let's see. So let's go to my project. So I already created a project called e-commerce portal. This is the e-commerce portal. Let me commit what are the changes I have made. So okay, miscellaneous changes I have done. Okay, added some files, commit, push. It will throw like this pop up. You can just click OK. So now go to here. So just verify app pipelines, backend, so front end and ISC folder, pre-requests, dev, prod. So okay. Now we are going to create our first pipeline. Go to pipelines. So here we don't have any pipelines. We'll try to create one pipeline. So select the repository. This is the pipeline name, pre-infra pipeline. Okay, select that one. Click create, view your pipeline, click run, it will create. So check the logs. Okay, you need to grant the permission for your pipeline. So this is currently I am using my own pipeline engine. So if you are using your Azure based pipeline, it won't ask like this. Okay, so just remember this point. So go here and rename it pre-infra. Okay, save. Click this one. Okay, just observe the logs. Install latest version. Okay, so this Terraform already installed, so it's just throwing the version 1.132. Okay, so it is throwing some warning. So we have 1.13.3. This is just a one version only, no problem. So Terraform init. Okay, Terraform validate. So Terraform plan. So it will show you what are the resources going to create. So Azure Container Registry, Azure Resource Group. Okay, just refresh. So first it is trying to create Azure Resource Group. Okay, Azure Resource Group is completed. Let's verify that one. Still it is not reflected. Let me complete the pipeline. Yeah, pipeline is completed. Yeah. Okay. Two resources are created: Azure Container Registry, Azure Resource Group. Go and verify. Refresh this portal. Yeah. So here it is created. So Perplex e-commerce dev plus reg. Okay. So I have given the project name is Perplex. This is the application name. Okay. So container registry is created. You click that one. This is the container registry. Okay. So go to repositories. So currently we don't have any repositories. This is the first time we have created, right? Okay. So now we have completed the pre-infra pipeline. Let's see the infra pipeline. Go to infra pipeline. So infra pipeline. The same steps, but working directory is IAC. Okay. Let's see. Let's create that one also. This will take some time to create. We will just observe the logs. From portal. What is that name? From. Okay. Run. So grant permission to agent. So since I'm using my own pipeline, so my pipeline agent, so that it will ask me for permission. Rename it. Rename this. Click that one. Go here. So this will take some time to create. So Terraform unit is completed, but Terraform apply will take a lot of time. So you need to create the cluster right, so that it will creating a lot of time. So you can observe here. So Kubernetes cluster is creating, started creating. So pipeline is created successfully. So go and verify the resources. So AKS is created, and so we have created a one role. Okay, two resources are created. So it is completed. Go to home. So go here and verify the resource group. Just refresh here. Okay, container registry. Okay, and container services, Kubernetes services. Okay, so again we need to verify one more thing, that is, so role. So where did it created? So go here. So let me show that code. ASC .tf code. So this is the role assignment. Okay. So this registry, Azure Container Registry, should have access of ACR pool to this Kubernetes cluster. So that means, so this Kubernetes cluster will be able to access the Azure Container Registry. So it will be used for only ACR pool. That means for pulling the image purpose only, we are using this role assignment. Okay. So let's go and verify. So where can we verify? So go to, use the Azure, go to container registry, go to IAM, go to role assignment. Yeah, see, here it is created. So ACR full. This is the container registry. So role assignments. So it is having a ACR role assignment for this specific role or specific AKS. Okay, agent pool. Okay, so we have this AKS is installed in agents, right? So that agents have capable to pull this container registry image. Okay, so like this we need to verify. So with this you have completed infra pipeline and pre-infra pipeline. So now we need to, so now pre-infra is completed. Now come to ingress installation. So let's see the architecture. So now all parts are completed. So we have created Azure Container Registry, we have created a Kubernetes services. So now we need to install the Nginx load balancer. Okay. So why it should require? So in order to access your front-end application to external world, we should require some load balancer. We should require some Ingress load balancer. Okay. You can install that one. So if you install means, so with the help of a ingress, we can able to access the front end to public. Okay. So let's go to that pipeline. This is the ingress.yml. Yeah. So these are the key variables. We need to provide the which AKS we are going to install. This is the AKS name. This is the cluster resource group. This is the namespace. This is the ingress release name. So these are the variables. Okay. So these two is helpful to create a Nginx load balancer. Okay. So let's go to the what are the steps they have included. So they are telling to install the Helm tool. So after that, this will be helpful to log into that specific AKS. AZ AKS get credentials resource group. You need to pass the cluster resource group and cluster name. Okay. So that it can able to access now. Now it will be accessed. Okay. So we will asking how why it is why the Azure DevOps is able to connect to Azure portal. So you have already configured the service principal that will be acting as a service connection. Okay. With this we can establish a service connection between portal and Azure DevOps. Okay. So now come to main step. So this script will be installing your Nginx load balancer using the Helm. Okay. This is the Helm repo add. You need to pass this ingress nginx and this is the URL. Okay. So it will this is the package. This will package will be installing. So after that Helm repo update. So it will be updating. After that it will be installing your nginx controller. Okay. So you can see the command nginx upgrade install ingress release name. This is the image name nginx dash nginx. Okay, again nginx dash nginx namespace and create namespace control dot service type is equal to load balancer and replicas count is equal to 2 and node selector linux. Okay, they are using only linux only. After that they are opening the ports 80443. Okay, so my front end application is also running in 80 port only. Okay, after they are plotting some external traffic policy locally. So this step will be help to create the nginx load balancer. Okay, let's try to build the let's try to build this one. So go here, create the pipeline, e-commerce portal. So existing pipeline, select your nginx. Okay, review this, click create. Grant the permission. So come home directory, just rename. You can give any name, ingress or nginx or whatever it is. So better to give nginx, ingress. Can observe the logs. So Helm is installing the yeah, wait. So it is okay. This is the Kubernetes config. Okay. So now come to Nginx installation. Yeah, updated successfully. Happy Helmi. So it is suggesting how to use the ingress. Okay. The same we have followed. This is the ingress path. Okay. We are using the same one. Tool post. So we don't have any specific DNS, so that we are using a path like this. So I already show you, right? We don't have DNS, so that we are using that one ingress. So this is a dummy name. Okay, it's already existing one. Okay, this is the public IP, and these are you can kept anything. Okay, so this process I already followed from Kubernetes portal only. So HTTP portal prefixes service path. Okay. So this is the front end. Okay. So by default it will be going to front end. If there is any changes detected in path, so then it will be routing to your corresponding backend services. So if the TL is enabled for infra, we can do this one. So currently we don't have any TLS. Okay. So TLS is nothing but it is a secure landing page. Okay. So it is certified landing page. Okay. So if you have your own your own page, you can configure this one with the help of TLS certifications. Okay, this will create a secret and key, so that only will help to secure the strong login. Okay, so with this we have completed all the components. So let's go here. So we have completed the content registry, resource group completed, IAM role completed, AKS completed, and Nginx load balancer completed. So now we need to create all internal parts. Okay. So these all things we need to require. So first of all, we need to create a front end. So if you create the front end means this front end will be creating these all parts. This all front end pipeline will be creating this all part. So after that we need to create a backend pipeline. This pipeline will be creating all these parts. Okay. With this you complete this pipeline setup. Let's see. So till now we have completed infra pipeline, and Nginx pipeline. Okay, so it will provision this Azure Content Registry, and it will provision this RBAC role, and Nginx load balancer also completed. So we have already provisioned the Azure Content Kubernetes services. So the only part we are pending is this front end. This is front end, back end, and the database services and the deployments. Okay, let's do that one also. Okay, so front end pipeline. So So in order to, first of all, we need to build and publish the Docker file image to ACR, and then we need to deploy to the AKS. So that means we need to build that React.js application, and we need to publish this using Docker file. We need to publish this to ACR, and then we need to deploy to AKS. Okay, let's see the front end pipeline. So go to front end pipeline. Then let's see the steps. Okay. Okay, so this is the front end pipeline. So when a change is detected in the specific folder, so we have ecom.frontend. This is the folder name we have given for creation of frontend. So when this change is detected, so this pipeline will be triggering for this branch, this specific branch. Okay. So after that, we have passed some variables, so which included variable group. So ACR credentials. Okay. So it will having the ACR username and password. So when the Docker image is ready, we need to push these two ACR, right? So for that purpose, we need to require credentials. Okay. After that, subscription. Okay. This is the service connection. So after that, we need to give the AKS details, AKS resource group, AKS cluster name, and the ACR login server details, and image name, and manifest path, and image tag. Okay. So I will explain you where we are using this one. Okay. So we are using a full image. Yeah. Let's see. Stage 1. So in the stage 1, we will build and push the Docker image. The stage 2 will deploy that Docker image to the AKS. Okay. Okay. Let's see step 1. So build and pushing the Docker image. So these are the steps we have. So we have two main important jobs, two more scripts. So script 1. So these steps will help to log into the ACR. Okay. So why we need to log into ACR? Because we need to push our Docker image to ACR, right? So for that first we need to require the ACR username, ACR login server, ACR password. Okay. So ACR login server. So here we are importing from here ACR login server. This is the login server. Okay. So which I copied and pasted here from the portal. So after that we have ACR username, ACR password. So these two things are how shared in ACR credential. Okay. Okay. So once the login to ACR, So after that we need to build and we need to push to the container registry. So we have the same commands you are passing. So change related to ecom front end. Okay. After that we go to docker build hyphen t server name, login server name, image name, and image tag and current directory. So in the this specific folder with the Docker file on current location, it is going to build. Okay. So once it is building, so it is pushing to the this specific location, the same location. Okay. This is the step one. So now the image is sorry. This is the image. So now the image is pushed to the ACR container registry. Now after that, what should you do? You need to deploy this container registry to these containers Kubernetes services. Okay. So let's see how we do. So stage two, we need to deploy to AKS. Okay. So this will be triggering based upon stage one. Okay. Once the stage one is completed, then stage two is will be triggering. Okay. So it having the two main important tasks. Okay. So task one. So it will be logging to the your Kubernetes cluster. Okay. AKS, this is the command to log into your Kubernetes cluster. Okay. So it will importing the config. Okay. Kubernetes config. Okay. So after that, once logging, we need to deploy. So with the help of a kubectl, we need to deploy your Kubernetes manifest. So it will go, we need to give the command kubectl apply -f manifest path. So we already given the manifest path here. So Kubernetes manifest path. So ecom frontend slash Kubernetes. Okay. The same directory we have already. Okay. So it will be going to install there. Okay. After installing this all Kubernetes components, so we need to set the latest image. Okay. In the Kubernetes script we have image, right? So this image, right? Latest. So now it will be updating with your image tag. Okay. This image tag will be the same image tag of whatever you are pushing to the content registry. Okay, the same image tag is going to build. So for each every pipeline build, it will generating a unique build ID. Okay, so once you will started this stage, it will be generating a some build ID. Same build ID will be pushing to the content registry. The same will be updating in the Kubernetes services. Okay. Okay, let's say the Kubernetes. So we have deployment YAML, we have ingress.yml, we have series.yml. So go to ingress.yml. So we required a host ID. So since we are using a dummy ID, this is the Nginx. We have Nginx controller public IP. Okay. So to access the front end URL, you should require a public IP. Okay. So I need to collect the public IP from Kubernetes cluster. Okay. So go there. Yeah. So this is the AKS. So just verify all the components of a Kubernetes. So I didn't show you how it is created. Okay, this is the dashboard of AKS. So it is running subscription we have. This is the API server address. Okay, these are the Kubernetes properties. Okay, go to Kubernetes resources. Go to Kubernetes workloads. So this is very slow. This portal will be very slow. So instead of this one, you can use your own CL line. So that one also I will show you how to do. So you can see the workloads. Ingress Nginx controller. So we have installed the Ingress Nginx controller. Okay. Nginx load balancer. Okay. You already installed. Okay. This will having this one part. Okay. You can check here. Nginx part. Yeah. Ingress Nginx controller. Okay. Having its own name. Okay. Go to services and ingresses. Yeah, this Nginx load balancer will generate a external IP, that is public IP. Okay, you can click that one. One at one. So till now our front end is not up and running. So we need to do that one. So we need to install our front end so that then only we can able to access. Okay, first of all we need to deploy that one. Let's go to front end. So I will try to install, I will try to update this IP address. What is this? So copy this one, update in your ingress. Okay, save. Okay, and also the front end, first of all you need to push right. You need to push the Docker image to ACR. Okay, so for this purpose I need to color the ACR credentials. Go there, go to ACR, color the ACR credentials, access keys. Yeah, copy the username and password. So copy. Okay, go to pipeline. You have library. You have ACR credentials. You have username and password. You can paste that one. You can save. Okay. So now go here. So I made some change, right? I need to commit that one. So first what we will do? So first we will create a front end pipeline. After that we will update. So just refresh this one. Sometimes it will be very slow. Okay. So e-commerce portal, front end pipeline. Click continue. Just review the code. Run. Allow to use the ACR credentials. Okay. Granted permission. So for front end and back end pipelines, I'm using Azure pipelines. Okay. So I didn't change anything. So it is using the same pipelines only. That's not an issue. Yeah. So in meanwhile, okay, we can change the name. Rename. And then dash pipeline. So now see, Docker build is started. So npm install is running. So now the production build is running. So now the push is happening. Pushing reference repository. This is the repository. The tag is 532. Okay. So let's say once it is pushed, we can verify. Yeah. So the build and push is completed. This is the 532. So go the container registry, verify the repository. So you come front end. Okay, here we go. So you can see the tag 535. Okay. So now build is completed, build and push is completed. Now deploy. So this will take some time. Just refresh the page. Yeah. Okay. Qconfig is configured as a okay, current directory. Okay. So deploying the manifest dot. Okay. Yeah. Wait. Let's see the. Okay. kubectl is deploying our resources. So deploying the manifest from the specific location. So front-end deployment is created. Okay. Ingress is created and service is created. Okay. So image is updated. Okay. Now let's see. So go to AKS. So it is very difficult to work with this GUI. Each and every time we need to go and we need to check the deployment spots, right? The front end is yeah front end deployment is completed. Okay, it is deployed successfully. So let's verify our public API. Refresh. No, page is not loading. Why? Because you are not updated the public API in Ingress. So this is new one. So in the front end we have the Ingress we have new one. This is old one. So now I have changed. Okay. Now let me deploy this new one. Added new IP. Okay. Okay. So now the front end pipeline will be triggering automatically. So go here. So let's wait for auto trigger. Yeah, here we go. So front end pipeline. Yeah, you can observe the logs. So once this is deployed, you can able to see your portal in this public IP. So now the pipeline is completed. Okay. So it is updated. Yeah, let's go. So just reload this IP. Yeah, sorry, this is not the portal, I guess. So we need to open this one. This is the port we have configured. Yeah, here we go. So e-commerce front-end portal. Okay, not the this is a public IP only. So this is the public IP host name. Okay, this is the correct one. So now we have completed the front-end pipeline. Let's see the back-end pipeline. So this part is completed. So now come to this part. Okay, let's see. So till now we have completed the front-end pipeline. So it will be build and deploy this portion, front-end portion it will is completed. So now we will deploy the back-end portion. Okay. So it will deploy the back-end Spring Boot application and database MySQL. Okay. Let's see the back-end pipeline. Okay. So this is the similar to the front-end pipeline only. So we need to pass the variables. So sorry. So first of all starts with trigger. So based upon changes in backend, so this pipeline will trigger on a main branch. Okay. So it should contain the variables. Okay, the same variables which I mentioned in the front end. Okay, cluster details, ACR details, and the image name, and the Kubernetes manifest, image tag, and the ACR credentials, Azure service connection. Okay, so it having the two stages. One is build and push to the Docker image. Two is deploying to AKS. Okay, in the stage one, so it will be building your application and publishing to ACR. Okay, stage two, so it will log into your cluster and it will be deploying your Kubernetes manifest. After that, it will updating uh, your image. Okay. So since we are having only backend image, so it will just updating with your image ID. Okay. Let's see. Let's go to, yeah. Let's go to pipelines. So we have pipelines. Front end is completed. Backend. So select git commerce. Sorry, pipeline. So let's see the logs of this portal. So this will take some time. So pipeline is successfully completed. So let's see. Okay, this is the Spring Boot application that we having lot of compiling compiling things. So this is the ecom image name, and this is the tab 534. Go there. Okay, contain registry. Can verify. So here we go. Ecom backend. Okay. So I given the name as ecom backend. Okay. So for name consistency, I given the like this. The image is I think 534. Yeah. So same image is published, and so you can go to AKS and cross verify. So instead of going every time and checking cross checking all the images, it is very difficult. So now we will do some commands so that we can I will know that all the things. So I'll give you a Terraform commands, sorry, Kubernetes commands that will that will get you the Kubernetes CL line. Okay, so pass that command. So this help us to interact with your Kubernetes cluster. Okay, kubectl get yeah, here we go. So here we have two parts, two front end, one MySQL. This is the services. This is the deployments. This is the replica sets. Okay, all we have. Okay, fine. All under run state only. So with this, you can confirm all the all the parts are deployed successfully. See, so we have deployed all the infra resources. We have deployed front end. We have deployed back end. We have deployed MySQL. Okay. So you can just cross verify. So you have some commands to ctl drive deploy dash front end. Okay, so it will tell you about your deployment, front end deployment. Okay, so port 80 you are enabled. Okay, replica set is 2. Okay, like this you can do for front end or back end the same. I'll do for MySQL. Yeah, it's having this all configurations. Okay, so I would like to check the logs of a specific pod. Okay, so it will get pods. So create here logs pod to take the first one only. Copy and paste here. So you can see the logs. Okay, so get, that means someone already are doing some get method. That means someone are able to viewing the front end application. Okay, see, get SSHV like this, they are doing something. Okay, so now what should we do? So front end is application. Front end we will try to book some. Okay, so backend application is completed. So we have clean up pipeline. So this we can do at the end of this session. Okay, so let's test this one. Mm, what should we do? So we have completed the backline. Let's see on next slide. Let's play. Yeah, six, application deployment and integration. So once infra pipeline is completed, we need to verify the resource groups and we need to cross check all the resources. So we have already cross checked all the resources are deployed successfully. So after that, we need to deploy the Spring Boot application to AKS. We already done that one. So we need to deploy the front end here JS to AKS. Okay. So we already done that one. So we need to integrate the front end and back end and DB. Okay. So we have already done that one. So front end is we can able to access front end to back end to DB. So we can do that one. So end-to-end testing of portal in the browser. Okay. We can do that one. Yeah, now let's do the end-to-end testing. Okay, let's open our portal. So we have e-commerce shopping portal. Okay, so click I would like to buy this laptop. Okay, click that down, give the name, some menu one, and Jitram. Okay, and India, need to use some number. Okay, place order. Okay, order is placed. So now you are confirmed that so order is placed. Now this order details will be go to the backend team. Okay, so how can we confirm that backend team is received this order? Okay, let's check that one. So cube it here, get okay, cube it here, log, right, cube it here. Yeah, this is the stopping entry. Yeah. So here you can't see the orders. So the best approach to check the database details is I will show you how tester some commands. Okay. So, you need to create a temporary container. So take this one. So this command. So paste this one. This command will be creating a temporary container. So once the work is completed, this will be deleting automatically. Okay. So inside the once the pod is created, inside the pod, you need to execute this one. Paste. So you need to paste the user password. Okay. So I have given ecompass, ECOMPASS. Okay. So connection is established. So from my temporary container, temporary pod to your MySQL original pod, it is connected. Okay, let's see. So now how to check the details. Okay, you need to pass some DB queries. No, command is not correct. You need to copy the full command. Okay, so it's showing some databases, e-commerce information schema, performance schema. Okay, so my database is e-commerce only. So I already mentioned the database details in the backend resource file application.property only. So database.username password, and we need to use the database of here. So this is the database details. Okay, wait. Let me cross check in the console. Yeah. So we have only one e-commerce DB only. So by default, it will be going to that DB only. Okay. So we have another two DBs. This is not a DB. This is a schemas. So we have only e-commerce DB only. So all data will be go to that e-commerce only. So let's go to our commands. Let's check the database. Use ecom paste. Okay, database changed. So we are using the e-commerce database only now. Show that tables, paste. So we have only one table, order item. So I would like to check all the items in all the details in order item. Yeah, here we go. So you can see here. So customer address, India, Bangalore, something like that. Customer names, person name, from. So customer phone number, customer price, and the product name. Okay. So this customer is purchased this product with the price. This one is the phone number. This is home. This customer detail, the address. Okay. So now the customer is having its own portal. Okay. So he can able to view and he can able to deliver this product to his home address. Okay. Like this, we need to we have confirmed that. So end-to-end deployment is completed. This e-commerce project. Okay. So let's see. Flow is completed. So from front end to back end to DB. So we have confirmed that order is placed. Okay. So let's do one more thing. So phone. We can do something. Okay. Place order. So order place. Okay. So now go and check this one. Yeah. So Meghna Chaudhary. This order is confirmed. Okay. So like this, you need to do end-to-end deployment of e-commerce application. So since this is a very minimal application, we have done some minimal effort only. So if you would like to do some realistic projects, you can create a original DBs, you can create a multiple backend services, you can create a good GUI look of React.js, you can use AngularJS, you can use some VT, you can use some another flavors also. Okay. So from from here, so we have completed all the application deployments. Okay. Let's see next one. So monitoring observabilities. So we have already checked how to check the logs of the pods. Okay. So I have given the commands. Okay. So I already pasted the commands here also. You can check this one. So go to kubectl logs and give the command. So if you don't need this command means you can close this one. So you can go here. So go to workloads. You can check go to each and every pod. So go to pods. This page is very slow. Okay. So check the pods each and every pod. Okay. Or you need to require. Okay. This is the you need to check the live logs. Okay. This is very difficult. Instead of this one, you can directly pass the command. Okay, you can check the logs. Okay, so you can already check that the build fails and build deployments. Okay, you can view the logs there itself. So after that, clean up pipeline. Okay, let's just try each and everything. Yeah, this one you can check the logs. So this AKS is a very slow when come to GUI part. So if you go for CLI apartments, it is very good. So see the stream logs are loading. So if I pass the command kubectl logs front end this pod name, so it will be showing directly. So now it is very slow. Okay, come to back. So we have our own services and the ingresses, right? This is one ingresses. So this is my ingress, front end ingress. Okay, this is the host name, this is the address name. Okay, instead of hoster you can give the address also fine, but in the ingress in the front end ingress I have given the host name. Okay, let me create the front end. So let me create the pipeline, cleanup pipeline, so that will destroy all your resources. Cleanup. Okay, continue. So rename, cleanup. So it is destroying all the resources. We need to wait for some time to destroy. So pipeline is successful. So all the results are delivered successfully. Okay. So you can just cross verify. To destroy. Okay. Cluster is destroyed. So we will delete them manually. So your ACR will be deleted manually. Okay. AKS deleted. So let me delete the. So let me delete this resource group and content registry separately. If you delete resource group, so under the all resources will be deleting. Okay. So okay, these are now the errors will be deleted. Now come to Okay. Cleanup pipeline is completed. So with this, you have completed the end-to-end development of a e-commerce portal. Okay. So let's quick revision. Okay. So we have done front-end and back-end development and deployment of your application, and we have done Terraform automation. So we have learned how to create the Azure pipelines. So we have learned what are the services about AKS and ACR. So we have learned how to create a Docker file and Kubernetes manifest, and we have learned how to deploy Nginx controller using Helm. Okay. So next one. So till now we have completed three projects. Now come to fourth project. So that is hospital booking portal. So in this project we are used to AKS and ACR only. So next project we are using original MySQL. So in this application we are using MySQL pod. Okay. Next one we are using our original MySQL. Okay. So we are using virtual network. So it is a more secure one. This is a more practical one. Okay. Okay, that is the my next advanced project. Okay, thank you. So it's your Prasanna Kumar. Thank you.